A complex number is denoted by Z. Z equals to A plus IB. That means a complex number is having two parts. One is a A, another second part is a IB. A is nothing but called real part of complex number, and IB, that is nothing but called imaginary part of complex number. So a complex number is a combination of real part and imaginary part. Example Z equals to 2 plus I3. You see, we can write I3 or we can write 2 plus 3I. In some books it is written as a I3, and in the some books it is written as a 3I. In our tutorial we shall be writing I latter and the number first, like Z equals to 4 plus 5I. This way we are going to write. So a complex number having two parts, one is a real part, another is a imaginary part. If there are more than two or three complex number, then first complex number can be denoted as a Z1. Z1 equals to 3 plus 4I. Z2 equals to 6 minus 4I. Z3 equals to 5 plus 6I. This way we can write. If there are more than one complex number given to us, then the different complex numbers can be written by Z1, Z2, Z3, Z4, etc. Complex number can be represented by using Argand's diagram. Detailed explanation about Argand's diagram I have given in episode 5. In this episode, I am just giving you the brief information about Argand's diagram. In Argand's diagram, x-axis is taken as real axis and y-axis is taken as an imaginary axis. Let us represent few complex number in Argand's diagram, such as Z equals to 4 plus 5I, Z equals to minus 7 plus 3I, Z equals to minus 10 minus 3I, Z equals to 8 minus 2I are represented same as we represent in two-dimensional geometry. Complex numbers can be added, can be subtracted, can be multiplied, and can be divided. So these are the four algebraic operations are possible with the help of complex number. So the addition of complex number, subtraction of the complex number, multiplication of complex number, and the division of the complex number is possible. Let us take some examples on addition, subtraction, multiplication, and division of complex numbers. Suppose we are having first complex number 2 plus 3I and second complex number 6I plus 8, and the third complex number 4 plus 5I. So we need to add complex numbers, three complex numbers. So what you do? You write down Z1, that is a 2 plus 3I. Then you write down Z2, write such that the imaginary part come below the imaginary part. In the Z2, what is there? Z2 is equal to 6I plus 8. So what you do? You write first the similar part together. So in the Z1 we written real part first. So in Z2 also we write the real part first, 8 plus 6I, and Z3 equal to automatically is arranged. The real part is first there, so we don't mind. So 4 plus 5I. Then we add all the real parts, that is a 10 plus 14, 2 plus 8, 10, and 10 plus 4, 14, and here the 3 plus 6, 9, 9 plus 5, 14, so 14i. So we got here the 14 plus 14i. So that is nothing but Z1 plus Z2 plus Z3. This way we can add the complex numbers. Now the next question is that can we multiply a number with a complex number? Example, suppose Z1 equals to 4 plus 5i is there. So you are asking, can you multiply like 3Z1? Or your question is how to find out 3Z1? So answer is yes, we can multiply a given complex number with any scalar number. So Z1 equals to 4 plus 5i, then how to find out 3Z1? So 3Z1 can be find out 3 into Z1, that is 4 plus 5i. So that is equals to 3 into 4 plus 3 into 5. It is like ordinary algebra now. So 3 into 4, 12, and 3 into 5, 15. So 12 plus 15i. So the result of 3Z1 equals to 12 plus 15i. One more example, Z2 is equal to 3 minus 6i. So suppose you wish to find out 4Z2 equals to how much? Then 4 into Z2, that is at 3 minus 6i, that is equals to 4 into 3 minus 4 into 6i, that is equals to 12 minus 24i. So that is the result of 4Z2. Thus we can multiply a given complex number with any number. Suppose Z1 equals to 3 minus 4i, Z2 equals to 3, let us say 8 plus 2i. Z1 equals to 3 minus 4i, Z2 equals to 8 plus 2i. Find 2Z1 plus 3Z2. How to find out that? So solution. So we need to find out 2Z1 plus 3Z2. So that is equals to 2 into, in place of Z1, 3 minus 4i plus 3 into Z2. In place of Z2, 8 plus 2i. Then 2 into 3 minus 2 into 4i plus 3 into 8 plus 3 into 2i, that is equals to 6 minus 8i and 24 plus 6i. Now we bring real part together, 6 plus 24, group them, and imaginary part together, that is minus 8i plus 6i. So here is a 30, and here we can take I common, minus 8 plus 6. So 30 plus I minus 2. So that is equals to 30 minus 2i. So that is the result of 2Z1 plus 3Z2 equals to 30 minus 2i. Now next question is Z1 equals to 6 plus 7i, Z2 equals to 8 plus 2i. Find the value of Z1 plus 3 upon 2 Z2. Solution. We need to find out Z1 plus 3 upon 2 Z2, that is equals to 2Z1 plus 3 Z2 upon 2. If I directly do it, then this fractional part will trouble us later on. So first I simplified it. Now I will operate it. So 1 by 2 is taken outside. Now 2Z1 plus 3Z2, that is equals to 1 by 2, 2Z1, Z1 nothing but 6 plus 7i plus 3Z2, that is 8 plus 2i. Now what we do? We simplify the terms. So 12 plus 14i and 24 plus 6i. Then we bring the real parts together. The real parts are 12 plus 24 and imaginary parts are 14i plus 6i. Here 1 by 2. Then the addition of real part 12 plus 24, that is 36, and we take I common, then 14 plus 6. 14 plus 6 equals to 20. That is equals to 1 by 2, 36 plus I plus 20i, that is a 20. 1 by 2, 36 plus 20i. If possible, take common, suitable common, so that these two will get cancelled. Need not be cancelled, but if it is getting cancelled, okay. If not getting cancelled, then also it's okay. Now I have taken 2 common, so 18 plus 10i. These 2 and 2 get cancelled. Therefore Z1 plus 3 by 2 Z2 equals to 18 plus 10i. This way, even if fractional parts are present, then also we can add complex numbers. Now suppose we have the two complex number in which the decimal parts are present, then how to add them? For example, Z1 equals to 1 plus 0.5i and Z2 equals to 3.2 plus 1.4i. Then find Z1 plus Z2. So in this problem, what we can do? We write Z1 1 plus 0.5i. We can add both in a horizontal way and the vertical way. First let me do in vertical way, then we'll do horizontal way. And Z2 equals to 3.2 1.4i. We write real part below the real part and imaginary part below the imaginary part. Then we add as usual, that is 1.0 plus 3.2, that is 4.2. So this becomes 4.2, and 0.5 1.4, that is equals to 1.9i. Therefore Z1 plus Z2 equals to 4.2 plus 1.9i. This way we can add two complex numbers even decimal parts are present. Now same problem I will solve you how to add horizontally. Z1 plus Z2 equals to 1 plus 0.5i plus 3.2 plus 1.4i. What we do now? We add the real parts together, that is 1 plus 3.2, and imaginary part together 0.5i plus 1.4i. So that is equals to 1 plus 3.2, that is 4.2, and 0.5 and 1.4, that is 1.9i. This way Z1 plus Z2 equals to 4.2 plus 1.9i. This way even we can add horizontally or we can add vertically. Now consider another example. Z1 equals to 4i. In this complex number, only imaginary part is present. In case of the Z2, the 4 only present, and in case of Z3, both are present. So how to add Z1 plus Z2 plus Z3? So let us add them horizontally. Z1 plus Z2 plus Z3. The first complex number can be written as, it is a Z1 equals to 4i. Therefore Z1 can be written as 0 plus 4i. So 0 plus 4i. And Z2 given as a 4, only 4, where I part is not there. Therefore Z2 can be written as 4 plus 0i. 4 plus 0i. Then the third complex number is a 8 plus 4i. Now adding all the real part, 0 plus 4 plus 8. adding all the imaginary part 4i, 0i plus 4i equals to 12 plus I taken common here, 4 plus 0 plus 4, that is equals to 12 plus 8i. Therefore, Z1 plus Z2 plus Z3 equals to 12 plus 8i. This is required answer. Next example, if Z1 equals to 1 by 2 plus 3 by 2i and Z2 equals to 1 upon 7 plus 4 upon 5i, find Z1 plus Z2 equals to how much? Here the solution remain the same, that is addition of all real parts and all imaginary parts. Only thing is that first we'll bring all the real parts together, that is 1 by 2 plus 1 by 7 together, then I common, then write all the numbers 3 by 2 plus 4 by 5. After that we add this fraction as usual we do addition of the fraction. Same way we are going to add the fraction now, that is 7 plus 2 upon 7 into 2 plus I 3 into 5 plus 4 into 2 upon 2 into 5. So that is equals to 9 upon 14 plus I 15 plus 8 upon 10, that is equals to 9 upon 14 plus I and 23 upon 10. So the result is Z1 plus Z2 equals to 9 upon 14, 23 upon 10i. This is the required result. If you can take some common, you can take, so for example 14 and 10, so the 2 is common, 1 by 2 is common, so we can write 9 upon 7 plus 23 upon 5i. So this way if common is possible either in denominator or numerator, you can take it. So this is required result of Z1 plus Z2. Now for multiplication of complex number and division of the complex number, please visit episode number 2 of the complex number given in my playlist.